Today, I will be showing you a step-by-step guide on how to perform a meta-analysis for binary outcome using SPSS. If you haven't already downloaded the CSV file from the description below, please do so for practical section. Let's go to SPSS and see how we can import the dataset. So if you have opened your SPSS this way, go to File, then Import, then click on CSV Data, because that is what we are importing. And you have done that, then pick the dataset which we have here, meta-analysis SPS binary level studies with label, and then click Open. When that open, ensure we have first line contain variable names, the comma, period, double quote, let it be that way, click OK. So when that happens, and then you can expand this for us to see, and expand this, and then this is our SPS dataset. So on the SPS dataset, you have here the study label, the study ID, study label, and then the treatment, yes, the treatments group, no, here, and then the control group, yes, and the control group, no. All right, yeah, that is clear. One important thing we need to also take note of this is that we have to run it. How do we run it? Go to Analyze, then click on Meta-Analysis, and take note that from SPSS version 28, you now have meta-analysis inbuilt in it, so you can use that. So click on meta-analysis, and then click on continuous outcomes, and then click on raw data. Okay. No, we are not running continuous, we are running binary. So please go to Analyze, Meta-Analysis, click on Binary Outcome. If you want to know how to run the continuous outcomes, then watch out for my lecture on that continuous outcomes. Then, because we are doing binary, so click on Binary Outcome, then click on Raw Data. So when that happens, one important aspect is that we need is you look, treatment group is here and control groups, and treatment group has success and failure. Control group also has success and failures, and study ID and study label. So this is our variables. So let's take study ID to study ID, study label to study label, treatment yes represent success. It means so we put in the success, treatment no to failure, then control yes to control success, control group to control group failure. All right. So after doing that, ensure we have log-odds ratio here. Tick is very important. You may wish to explore log-risk ratio or risk differences, but very important for us here, we are using log-odds ratio. And then the model here, ensure that random effect is tick. It's very important because we believe the various studies we included have different study design and from different study regions. So we are picking random effect. Then fixed effect here is if the study has homogeneity completely and similarities. In real world, oftentimes random effect is what happens. So on criteria here, you can tick on criteria, but leave it at default 95. So just click continue and analysis. So leave it the way it is at default. Inference, leave it that way. Then click on bias. On bias, you may wish to have eager test, which is important to know the extent to which some of these studies have biases or not. So if you have done that, you can click continue. So click on eager test here. You can explore that test, but for this important eager test, click, then click continue. And then on the trim and field, it's important to click on extreme number of missing studies to know which studies are missing or which are not. So you can click on it and all this will display. So when you have done that, just click continue. Then on the print, let's see the test of homogeneity, click on it and then heterogeneity measure, click on it, very important. Then see effect sizes across each individual study. It's important, so click on it. And when you have done that, click continue. Then on the plots here, save, don't click anything. On the plot, you may want to explore forest plot. There are a lot of plot, forest plot, bubble plot, funnel plot, Calbi plot, labor, Happy plot. So let's take the forest plot. So click on forest plot. When that is, then click, ensure you tick all these box: effect size, standard error, confidence interval, p-value, weight, and display exponential form, because they are important. And then when that is done, you may want to see reference line, which is very important. So click on it, overall effect size, overall effect size, and then null effect size. Also click on that. Then when that is done, if you want to explore funnel plot, you may also click funnel plot. And it's important. Okay, let's take funnel plot so that you may also see funnel plot. Let's take funnel plot, and then let's also take, let's do the funnel plot based on the study label. So let's take study label and put in here for you to show the study label, and then continue. So when that is done, then click OK. So when the result will display this way, and then you'll see from the result you have the meta-analysis summary here. We have the case processing summary informing us that 11 studies are included and there are no missing cases. And then on the effect size estimate, very important, the overall effect size here, this represents the log-odds ratio, which is different from log ratio, which is different from odds ratio. So this is the effect size here representing log-odds ratio is 0.473 overall. This is the overall estimated error for the 11 studies included, C-score for 11 studies, then the significant level for 11 studies, telling us that the study in overall statistically significant because they are less than 0.05. As you can see, this is the confidence interval for lower and upper confidence interval. Then this effect size estimates for individual studies. So these are individual studies 1 to 11, and these are the publishers of these articles and their studies label which we gave. And then these are the effect size for each studies, the standard error for each study, C-score for each studies, and then for significant level for each study. And if you look well, you're going to realize that among all of them is only one study that is statistically significant, Samson 2020, study number 4, that is statistically significant. It has 0.38, less than 0.05. Others are greater than 0.05, meaning that they are not statistically significant. And this one that is 0.055 is just at the borderline. And if we look at the confidence interval here, negative 0.016, and then upper is 1.5. It crosses the line one, it crosses once, therefore it's not statistically significant. These are weight, these are the weight percentages. Okay, then this is the heterogeneity of homogeneity. The study has low heterogeneity, and that is, then it is not statistically significant on homogeneity. Okay, that is, this also confirm it. The I squared is 0 here, and then the T square is the S squared is 1.000. So this is the ECA regression based test, informing us that there is no bias in the study because it's not significantly significant. Intercept is not statistically significant. You can also see the standard error here is 0.86. 7 is not statistically significant. So there is no publication bias in the studies included. On the trim and field analysis summary, you notice that effect size estimate for trim analysis, the observed and the observed imputed, there are no differences. Meaning that no imputation was done, which is good, appropriate. Number of imputed studies 0 here. Then for the forest plot, if you look deeply, you understand that we have study IDs, we have the study size for each of these are the study names, and then this is odds ratios. Is the odds ratio the conversion of the log odds which we had is what gave us this odds ratio. So this is the overall odds ratio 1.60, which tells us about 60% of those who received intervention perform better or have better or improved outcomes in their pregnancy than those who didn't receive the intervention. This is the lower and the upper confidence interval, and it's statistically significant. And this 1.6 we should have here is what we have here, 1.6 on this forest plot. This forest plot is just a pictorial presentation of this particular data formation table which we have here. So now if you look, the explanations are also stated here. Effect size of each study. So each of these blue boxes represent the effect size of each study that are included. And if you look, some are larger than some. The largeness of the box is determined by the weight here. So if you look at the weight percentage for this, which is large, is almost 10.969 for the weight percentage. Then for the weight itself is 6.87. So it's larger than these other ones. Okay, the smallest one, because the weight is small a bit. The here is 7. Okay, 0.9. So after doing that, you have to take note of this other icon here is estimated overall effect size. Okay, which we had. Remember, the overall estimated effect size was 0.4 something. You can go up to see there 0.4. So yeah, overall effect size 0.473. Okay, this overall effect size which you have here 0.473 is the conversion that gave us this 1.6, which is for the odds ratio. Remember, this overall effect size is log odds. Okay, now, and in addition to that, very important thing, these lines here are confidence interval, represent confidence interval, and this line here is a no effect value line. So whenever any of this confidence interval crosses this line, it means it's not significant. So you see, the only one that is significant here that does not cross the line is the number 4 study Samson 2020, which gave us which was statistical significance here as 0.04. Okay, the other ones cross this line. Okay, the one for the borderline is also cross the line. You can see that is 0.05 we had here. So then, in addition to that, you can also, this other ones here, this other vertical line here, it represents the overall confidence interval. Why each of these are for each study confidence interval. Then this is the funnel plot which we plotted, and we noticed that, look at the y-axis for standard error, and then the log odds ratio on the x-axis. And this is the 95%. This triangular line here indicating 95% pseudo confidence interval, and the distribution of the studies are within this the confidence interval and the angle, indicating that we actually have no bias in the publications. And then this is how you run your meta-analysis using binary outcomes. So thank you.